Hello and welcome to Lab Talk, a series of expert tips to help you get the most out of our products in your lab. My name is Angela Carnwright, and I'm here with you live from the Immersive Lab studio today. So very excited to be here. And I'm really pleased to introduce our topic today, how ULT usage, so ultra low freezer usage, affects energy consumption and overall performance. Today, I'm pleased to welcome Josh Lewis, one of our experts here at Thermo Fisher Scientific in the world of cold storage. Thank you so much for joining us today, Josh. I can't wait to hear about this awesome presentation.
Thank you, Angela. Welcome, everyone. As Angela mentioned, we're going to be talking about ultra-low temperature freezer usage and the effects that it has on energy consumption and overall performance. So let's go ahead and jump in. So first and foremost, a ULT, ultra temperature freezer, is designed to maintain sample temperature. So continual door openings, excessive loading, anytime you enter samples or product that is not already at the cabinet temperature imparts a heat load on that ULT freezer. And that will ultimately cause the freezer to work a little bit harder, right? And when any kind of mechanical system works harder, it consumes more energy. So we're gonna look at what the effects of that actually are and what we can do within our lab environment to minimize the effects of actual usage, because no one buys a freezer if they don't intend to actually use it. So first and foremost, a ULT freezer, when it's properly designed, is intended to maintain temperature throughout the entirety of the cabinet. So that's top to bottom, left to right. To do that, it has to be able to have refrigeration capacity to basically remove the heat from all areas of that cabinet effectively. When you do that, it requires more energy usage. So there are some freezers on the market that take a primary goal of energy consumption over cabinet control. The reason why that's critical to understand is if the first and foremost priority of a ULT is to maintain temperature, we can't sacrifice sample temperature control for that of energy consumption. They go hand in hand, right? To maintain cabinet temperature requires energy. One way that we've been able to combat that rising energy usage over the past, call it decade of ULT design, is taking into account variable speed compressor technology. So the ability to ramp up and ramp down the cooling capacity required to maintain that sample temperature depending on the type of usage that the ULT is involved with. When the doors are closed, middle of the night, and everything is kind of status quo, the required energy consumption is very low. It's minimal. Throughout the day, as you open that cabinet door, add product, remove product, right, the energy draw on that system is going to inevitably go up. So as we utilize that variable speed technology in our ULTs of today, we really ramp up and ramp down to maintain the best energy performance across the freezer that we can. Plain and simple, right? We're gonna show that in just a minute at the immersive lab. But when you open up the door, right, cold air from the cabinet escapes. Whether or not it falls out because you are opening up the cabinet, obviously you're imparting a heat load into the cabinet when you enter product or otherwise. Energy goes up, cabinet variation in temperature goes up. A well-designed cabinet, if we look at that graph there, as you open up that door and then close it, you'll see a temperature spike go up, but then immediately come back down. Successive door openings, you will see that temperature rise throughout the day. So it's important that we optimize cabinet temperature over energy consumption so that we don't expose our samples to continually warm environments. Okay, so that being said, what can we do from a lab environment? In the background, you're going to see the immersive lab team opening up a ULT door. What we need to understand, though, is the steps that we can take in preparation before we access that door. One, do you have a database of your samples throughout the cabinet? The reason why this is important is if you're standing in front of that ULT door, that open cabinet for just trying to find out where that sample is that you need, you're wasting valuable time, and time means energy, right? Taking advantage of programs like FreezerWorks or even a basic Excel program to map out where your samples are is critical to maintaining and optimizing the sustainability of your lab. The other aspect, almost all ULT freezers of today come with inner doors that separate the compartments. You'll notice that our immersive lab team opened up the topmost inner door of this ULT freezer. When you know where your sample is and you minimize the interior door access that you're opening, right? You're minimizing that cold air dropping out of that freezer. It kind of begs the next question as well, right? When it comes to preventative maintenance on a freezer, removing ice, making sure that everything is clear and clean will minimize the effects of door openings, because if your inner doors are frozen over or frost buildup is accumulated, you might intend to open one door and open up both. That means more cold leaves the cabinet, more heat enters. So as you'll notice, as we zoom back in on the user interface, that was a 60-second door opening. It was originally below -80 on the cabinet. You will see that temperature throughout that cabinet rise as that heat is circulated throughout the cabinet. If you were to progressively open up that cabinet door again in the next few minutes, that temperature is going to rise and rise, much like the graph that we were looking at previously. So it's critical that we, 1, minimize our door openings, 2, minimize the time that we open the door, and 3, we know where our samples are so that we're not spending time with that door open for no apparent reason. The next thing that we can do to really minimize the energy consumption on our ULT freezers is understanding which freezers within our fleet we're accessing more often than not. Inputting all of our samples that we're accessing on a daily basis or repetitively into a single freezer will ultimately cause that particular freezer to operate at a warmer environment more continuously. It's best, and it's the best advice we can give there is, if you have multiple freezers that you can access that are in the same area, spread out those samples between the long-term storage and your high-frequency access samples throughout your fleet. That will minimize the continual openings imparted on a single freezer. And last but not least, right, knowing the real intended use of a ULT freezer. While we've all put warm product inside of a freezer, it's almost inevitable. We do manufacture products on the market that are intended to bring samples from ambient condition down to a -70 or -80 condition in prep for entering into long-term storage. Things like blast freezers or control rate freezers, they help to minimize that added heat load that you're entering when you put samples into a ULT freezer. So really selecting the right equipment for your entirety of your workflow will even provide more efficiency when it comes to your overall fleet. So 3 things to do, right? Prepare before you open, minimize the openings that you're imparting on a single freezer, and utilizing the right product at the right time depending upon your workflow. When we do all that, right, things just, in summary, kind of looping back, our freezers, almost every freezer on the market today, regardless of manufacturer, they have built-in systems to record temperature, to record access, and we can really utilize that information effectively to monitor what our frequency of openings and access is. Independent monitoring systems can also do that as well. Optimizing your freezer usage across your fleet really takes into account the efficiencies of not only a single freezer but across that fleet, and minimizing the sample temperature spread of your product across the various freezers that you're accessing. Overall cost of ownership is not only just the equipment; it's also the HVAC system, right? As the freezer removes heat from the interior of the cabinet, it has to go somewhere. It goes into the unit, it goes into the room, right? So as you optimize the efficiency of your freezer, you are also optimizing the load or the capacity required in your facility as well. Track your samples, via programs like FreezerWorks and otherwise, to minimize that exposure that they have to warm environments when you open up your doors. And ultimately, that's going to drive better efficiency across your fleet, whether it be refrigerator, a freezer, or an ultra low. These tactics all play a part. So that's kind of it, right? The usage affects energy consumption hand in hand. The better we can control our usage of our cold storage products, the more effective we are, the lower energy consumption, and the more sustainable our overall lab is going to be. With that, I'm going to let Angela come back on.
Great tips today, Josh. Thank you so much for this awesome presentation. Everybody should tune in. We have a new topic next week. It is dPCR versus qPCR. So we're heading into molecular biology next week. We're going to talk about how to choose what is right for you and your project. So please tune in. Bring your lab mates, grab a coffee, join us for 15 minutes tutorial like we did today with Josh, and then bring your questions and have them ready. So thank you again, Josh, for a great session, and we'll see you next week.